Here we are, Unit 8 functions again, Day 3, slope from a table. So Day 1, we made the input and output tables using a function. Yesterday we found slope from a graph, and today we're finding it from a table. So we're finding how a line changes from the table. So slope, let's remind ourselves, slope is the constant change of a line. And we use the letter M to represent slope, and slope equals rise over run. And if you think about it, we rise along the y-axis, right? So it's really how y is changing. And when we run along the x-axis. So it's how the x changes. So rise over run is also how y is changing and how x is changing. So it's the change in y over your change in x. And one way to remember that is y over x. Why cry over your x? Why should you cry over your x? They're not worth it. So slope is the change in y divided by the change in x. So y over x, the change in y over the change in x. All right, so you can read this. It kind of tells you what we're about to do. I'm just going to jump right into it, though. So it's still rise over run. That doesn't change. But from the table, there is no graph. We can't see what we're rising or what we're running. So it's how is our y changing? How did 7 turn into 10? What did I do to get from 7 to 10? Did I add something? Did I subtract something? Our number got bigger, right? So we added, and we added 3. So how did my y change? We added 3. And how did my x change? So x, we're going to look at the x. How did I get from 2 to 4? Well, my number got bigger. What did I add or subtract? We added 2. So my slope here is 3/2. Sometimes it works out to where it's changing constantly, so it's a consistent change, so our slope will always be the same. Sometimes we might have a 6 and 4 and it reduces to 3/2. But it does just so happen that we're changing by 3, we're adding 3, we're adding 2, we're adding 2. Okay, and notice how I used 7 and 10, and I went straight across and went 2 to 4. So if I compared 7 and 10, I couldn't then jump down here and compare 6 and 8. I have to stay consistent with the ordered pair that I use. So remember, that's an ordered pair. Okay, so over here, we're going to start with our change in y. And oftentimes, students will accidentally come here to the x first because we oftentimes read left to right. So be very careful that we're doing the y over our x. So again, how is my y changing? How did I get from 1 to 5? What am I adding or subtracting? If I add 4, does that get me to 5? Yep. So I'm adding 4. And then how do I get from 5 to 4? I'm not adding 1 this time because 5 plus 1 is 6. I'm subtracting 1. So my change in x is -1. This answer is fine, but you also know this as -4. Sorry. So both answers are acceptable. You can leave 1 in your fraction, and I'll show you in a little bit, we just can't leave 0. So example C. I personally am going to jump down here. Like maybe I struggle with going from 20 to the teens. So I'm going to find an easy one. So sometimes I can avoid negatives. Sometimes I can avoid ones that I just don't want to do. So I'm going to jump down here and compare 7 and 2. So to get from 7 to 2, a lot of times we'll say we added 5. But that means I'm getting bigger. But I'm actually getting smaller. So be careful with that. We're subtracting 5. So my change in y is -5. And then if I'm comparing 7 and 2, I have to compare 10 and 12. And I grew here, so we're adding 2. So that's a +2. You can put the positive or not, it's up to you. But one negative exists, which is fine, so it's a -5/2. Okay, and remember, it doesn't really matter if you write it out front or with the 5, it doesn't really matter. All right, and here we go. Change in y. How is my y changing? Go ahead and do this on your own for a second. Press pause and do that. And we're subtracting. And over here, the question is, am I getting more negative or am I getting more positive? So I'm actually getting, so go think about that question. And I'm getting more negative. So if I'm getting more negative, I'm adding more negatives. So we're subtracting. Getting more negative, and the difference there is 2. Okay, and you can always write it right there and see. So same sign sum. We add, and my negative is bigger, so it does end up giving us -3. So my change there is -2. Well, this would not be an okay answer because we've got 2 negatives, and you need to know that that's 2 positives. 2 over 2 is a fine slope. An even better one would be 1. Okay, now let's go to the next page. You might notice here there's something different about our graph. So let's just start. Maybe you don't recognize it right away, and that's okay. So let's see. How does my y change? How do I get from 2 to 1? Don't mind my cursor there. 2 to 1, we're getting smaller, we're subtracting 1. So we have a -1. Okay, maybe you noticed, how do I get from 3 to 3? I'm not adding anything, and I'm not subtracting anything. So what represents nothing? What number represents nothing? 0. So we've got 0. Now this is not an okay answer to leave. You have to tell me if this is 0 or if this is undefined. And so remember that we cannot divide by 0. Dividing by 0 is not possible. And remember, our bottom number is the total. Can you have a total of 0 and give somebody an amount? And that's not possible. So our rise is 1 and our run is nothing. So we're not running here, and that'd be vertical. So the answer to this is undefined. Okay, make sure you don't leave your answer with a 0 in it. The answer has to be undefined. Now you're going to notice the opposite over here. Our change in y is nothing. We're not changing here. There is no change. But our change in x is we're adding 10. So now if I have a total, this is one way to think of it as a fraction. If I have a total of 10 of something, is it possible that you get nothing? And that's absolutely possible. And so if I get 0 out of 10, my answer is 0. Okay. The next 4 are for you to do for homework.